works in Rentley and for the past 4 or 5 years has been working as in Ruby, and she's one of the thoroughbreds who started her career in Ruby itself. Now that we've learned about performance, let's hear about common mistakes made during testing. She, by the way, is a Bharatnatyam dancer, so if anyone is interested to learn how to dance, talk to her. Over to you.
Beautiful. Yeah, thanks for the introduction. All right. Yeah. Okay, you might not see me because I'm much taller than everyone here. So I'll just stand here. So yeah, I'm Maheshwari Ramu from Rentley. And yeah, Subhajita has detailed well about our company. So we are actually a product-based company. We are both hardware and software provider and formed in 2011. And yeah, let's get into the topic today. So I was thinking about what to present well in the conf. So as a developer, we might have faced a lot of challenges. And I just wanted to spotlight one of the major issue that we face and the nightmare that we have on unit testing. So let's see about the common mistakes that make unit test cases flaky and how to avoid them. So here is the journey. First, we'll see about the test cases and the flaky test cases, what are all the flaky test cases and how that is impacting. And also we'll see about the common mistakes and the strategies to avoid them. And we'll conclude with the key points and the best practices. So what is test cases and why do we have test cases? So test case is nothing but it has the predefined condition and the input and the expected outcome. And that is basically, to test the chunk of code that you write is working as expected. And also, the impacted area that it already persists in the application is working and that is not impacting because of your new code insertion, right? And also it helps in identifying the issues. Major part we'll just check the corner cases. We would able to find the corner cases with the unit test case that we write, right? And that is like an integral part of the development. So let's move into flaky. What is flaky? So flaky is nothing but, sometimes your test cases passes and sometimes it's gonna fail. And it's like, without you're altering the code or without touching the code logic that you have written, it's gonna fail for some time. It's like fishy, right? So that's a flaky test cases, and there are a lot of factors that determine this flaky test cases or cause the flaky test cases. So first is like timing and the dependencies with third parties, and shade data, the random data. So we'll see other factors as well in the following up slides. And it has more impacts in terms of both development and the deployment lifecycle. That also we'll see in detail. Let's see this picture. So, we might have faced this a lot of time when we are, planning to deploy our code to the production and we are urging towards the release date. So what we tend to do in the CI/CD pipeline, we tend to rerun it, right? And keep rerunning it until it passes, rather, spending time on to the, flaky test cases and fixing it, right? But that's not a good idea. Rather, it's good to take all the flaky test cases and have a fix so that you'll have a smoother deployment. So let's see what all the impact it has on the flaky test cases, due to flaky test cases. So first is with the quality assessment. So the main reason that we write flaky the test cases is like to ensure the feature is working as expected, right? But that creates the problem when comes to the flakiness. And the quality, the trust factor that we have it on the test cases will be impacted because of this flakiness, where it produces the inconsistent outcome. And also the blocker of the production deployment, which is like a pain point for a developer who is trying to push their code into production. And it has the cost involved, which is more important when we come into the every organization where the cost is involved, right? So, and it doesn't stop there. It has the other impact as well, the maintenance and allocating the resource to debug it and fix it. Where it time consuming, and also the planned release schedule will also be impacted. Most of us might have faced this. So these are all the impacts that we have due to the flakiness in the test cases. So with these impacts said, what are we going to do with it? Are we going to stop writing test cases or comment all the test cases that we write in the application? Absolutely not, right? Or, just stop all the test cases because it's going to create the flakiness. And that's not the, right way to do, or, right way to have the process in the development, right? So let's see the common mistakes that make the test cases flaky. So with all the challenges that I have faced, I've just categorized this into 5 factors. So we'll see it, one by one. So first is timing and the synchronization issue. So this can be split into 4 parts here. So first is with asynchronous operations. So Rails, obviously, that has, involves with asynchronous operations. We can say, a background job that is running. So while writing test cases in such cases, so let's say you're, expecting your assertion is been running before the expected outcome is produced. Like say, for example, there is no proper wait time for your expected outcome before the assertion. It's gonna fail. So it's gonna produce the inconsistent outcome. And the next part is with database transaction. Mahesh has covered it well on the, deadlock and the race condition as well. So it's similar, while, writing the test cases, where by default Rails, wraps all the test cases inside the transaction. So, but when it deals with the external factors such as cache or, other factors that we have it in the application, it doesn't, the transaction doesn't work properly inside the test block that we write. So, that's going to create the synchronization issue. And the third part here is most important, that is timing. So most of our application deals with timing, right? So we might have write the test cases which is bounded with the timing. So in such cases, it is not advisable to have the perfect or the exact timing check in your test cases. And also we'll see how to avoid them. And last one is with time zone. So we know that the local server time zone and the CI/CD time zone is not the same, and that is also going to create the flakiness. We'll see the following for examples. So I have given a simple example with whatever I have faced and whatever we have faced in the Rently, and also it is like a simple example that you can see here. The scenario here is like I'm trying to take all the upcoming events that is, with the property, like there is a property model we have, and I'm trying to take all the schedules for the property, and here is the test case for that. So can you guys figure out where is the issue exactly here? Sorry? Start time. Exactly. So it's going to create a flakiness when it runs between 12 to 2. So the issue here is with the start time, you're right, so 2 hours ago. So this is not advisable. So whenever we write test case, we expect that it is going to fall under the same day. But when it runs between the time, between 12 to 1, 12 to 2, it's going to fail, right? So how we can avoid them? So there is an amazing, technique called time freezing, where you can freeze your timing of your test blocks, and also it's important to return the time, because if you did not return the time after that test cases, it's gonna fail, or it's gonna create the impact on the following up test cases. So that's one of the strategy that you can follow with timing. And the other one is with the time zone that I have mentioned. So it is sure that the time zone of your local server and CI/CD, it's going to be different, obviously. So without converting that into time zone of your application, again it's going to create an inconsistent outcome. So let's see with an quick example and the challenges I have faced, and I have applied this, and it stopped the inconsistent outcome. So here, can you guys quickly go over what is the issue here? Yeah, with different time zones. So you can see, like, the first time when I'm trying to convert it, so it's with offset plus 8. But in the second, you could see there is no offset, because of which it is producing the inconsistent outcome with respect to time. So how you can avoid them? You can make use of the Rails application with, there is a configuration where you can, give your application time zone, so that is more consistent. So here is the solution for it. So once you configure that with the application time zone, and you'll just convert that to what time zone. So here you could see just converting to the time doesn't work properly in all the cases. Rather configure it and make use of in time zone. Perfect. So next come to the second common mistake. So that is environment and the configuration problem. So here we can just split this into a two part. So first is fluctuation in the system resources. So here, like when you talk about the fluctuation in the system resource, that also leads to the flakiness. So, consider that you're writing the test cases where it has, lot of processor or the threads. Due to the, CPU availability or the scheduling change, it's going to change the, priority that has been set to the, threads. And that is going to affect the expected outcome based off of the priority that has been changed, right? So it is good to maintain the resource that is available, and keep the close monitoring to the throughput or the outcome of your result, mainly on the time that has been taken by your test suits. So if there is any fluctuation, and not only that, it affect the further test cases, it's going to create the failure on the performance related test cases. And the second part is like with the leakage. So what is play a role in terms of leakage in the test cases? So there are several part here that I have mentioned. So one is with the environment and the global definition. So please try not to mutate the global level definitions inside your test suits unless it's necessarily needed. And so let's see with a quick example. So here I was trying to mutate the email and the password which is in the global environment, and it was creating the flakiness in underlying test suits because I was not tear down, meaning I'm just setting up the the email and the password, the variables which is in the global level, but I'm not resetting it back to the original value, because of which it is creating the consistent, it is not producing the consistent outcome. So here is the example for that, and the strategy you can just avoid to avoid the flakiness. And third is non-isolated test cases. So this is also one of the major problem that we face on not properly organizing the test data that we create. So until and unless it is necessarily needed, or you're testing the the synchronization between the test cases, it is advisable to keep your test cases isolated. And fourth one is like dependencies on the third parties. So most of our application has the third-party integrations. So we write test cases to test, how the expected outcome that is from the third-party integrations. So here is like, most of the time it creates flakiness due to the inconsistent outcome from the third parties, or the rate limiting that they have, right? And the delay time between two different applications. So how to avoid these kind of flakiness in your application? So first I have provided the VCR. VCR is nothing but, it is like, the cassette where it's, record and replay whatever we have, inserted into. So for the first time, it's gonna hit the a real server and just record that into a memory. And for the, next consecutive runs, it will just, fetch it from the saved, and it is not going to hit the real server, from which you can just avoid the flakiness, and that produces the consistent outcome. And moving to the next, which is web mock. Most of us might have used this web mock to just mock your requests and responses. So it is advisable to have this when in terms of having the third-party integrations to avoid the inconsistencies. And I have given the three different areas how you can just mock your request and responses. First is stub, mock, and the double. So there is just few differences between these, where stub doesn't look into the behavior of your method and just stub the outcome of it. And the mock is nothing but just expect the method to be called. And double is the empty object that is being used to replace the real object. So these are all the examples I have provided how you can just mock your third party request. And last is lack of test data management, which is more important. So it is advisable to create the data based off of your request or the based off your test case that you write, which is wrapped in your scope of your test cases. Rather, depending on the existing data set that you have, that also will provide the inconsistent outcome. And all set. So we have went through all the common mistakes that make test cases flaky. Let's see how you can debug the flaky test cases. So first, when you run the test cases in when your test cases are getting executed in the CI/CD pipeline and you see there is an inconsistency, first you'll have to figure out whether that is because of your code or logic that you have written, or it's producing the really inconsistent outcome. That differentiation should be there before you are jumping into fixing the problem it creates. So next is categorize that. So we have seen 5 common mistakes, 5 different factors. So with that you should categorize under which it falls into, so that you are one step ahead or one step closer in fixing that issue. And last is most important, tracing in logs. So there is a mechanism where you can trace all the logs, especially the database states, and save it in the into the file and have it in the CI/CD pipeline for the quick reference, and you are more closer to the issue now to figure out and fix it. So these are all the debugging methods that you can follow. Next come the strategies to avoid them. So with these all common 5 common mistakes that we have seen, I have just categorized that into robust test data management. You should manage your data, like the input data that you create for the test cases properly, and proper timing and synchronization. Add a wait period until add a wait period when you have third-party integrations, or mainly using Capybara that we all about know. I'll just show that as well in the following slide. And isolate the test cases properly. Identify and manage the dependencies, like the couple of examples that I have given, and the strategies also I provided VCR and WebMock. You can make use of that. And the stable environment and configuration. Make sure your configuration is properly set, and that cleans all the data between the test cases. And I have provided other strategies as well based on the experience and also the challenges I have faced. So first is unordered collection. How that is creating the flakiness. So most of us here might have came across this situation. This is like when we are trying to create the records and checking it with whether it has been created with the set of examples that I have provided. So here is the example. So here I have taken the property again, which is checking whether these properties are active or not, and I'm expecting that active property should be equal to the array, which is property 1 and 2 that I have created. But it is not sure, or it is not 100% that it should be with the same properties that I have created, right? Because of the parallelism that it runs in the aspect, it is that a lot of other data might have also created in parallel, which might affect this such comparison of the assertions. So how you can avoid them? So best is to make use of match array or sorted by ID, so that you will get the consistent outcome. So here is the solution for that. You just use match array, so that it is sure that the properties or the examples that I have taken here. So properties that is giving the result is matching to the expected one that is being set. So next is randomness. So most of us have used randomness to just create the random number. Even that produces the inconsistent outcome. So I have just taken the example of the timing with respect to the timing here. So I'm randomly generating the number and appending to the time and setting the start and the end time. So here it is not advisable to have such randomness in terms of the time again. So it's better to have or explicitly test boundaries to set the test boundaries and the edge cases. So which make test cases more consistent. And let's move to the next one. So trusting that DB sequence will create a predictable ID. This is epic. So most of us might have expected that I have created this record. So this is the first record that I have created in the test, and you will just expect that ID will be 1 for sure, because that is the first record that I have created, right? But that's not be the case, like due to the parallelism again. So there are some data that has been created in the same table, at, in parallel way. So how you can avoid them? Rather comparing that with, the IED, expecting the perfect number to be there, fit in to the assertion, make use of the object that you have created so that it is more consistent. And let's come to the next one, which is explicitly setting the ID. So this is again an interesting one where we used to, set the ID while creation of the test data. So in such cases, again with this parallel mechanism that we have in the aspect, so there are some test cases which is running in parallel, but I've created the record with the same ID. So again, that is going to create a problem. Your assertion will fail. So how you can avoid them? So let's database do its own job on setting all the primary keys. So just expect the outcome of with the object or the elements that you're supposed to. And next is capybara system. So this is well known for the behavior test that we do. So what is the flakiness that it can create here? So it's like, again, due to the wait period that we have. So if we fail to wait for a certain time until the expected result has come, then again it's going to produce the inconsistent outcome. I have given a short example here. So what it is doing really is like you're just clicking a form and expecting that there should be a record created in the post. So the flakiness here is, let's say your assertion or the expectation is running before that part of request is completed, then for sure that post that you're expecting for would have not created in the database. Again, that creates the flakiness. So how to avoid them? There is a wonderful mechanism where you can have content to check whether particular content is ready and then check for whatever the count that we are expecting for. Next comes the tool to mitigate the flakiness. So this is more interesting, like what are all the tools? I have just provided based off of the challenges and the solution I have given. So first is parallel test execution. So execute your test cases parallel unless, if your testing framework supports parallelism, it's better to go with that option. But make sure it is thread safe and not dependent with each other, meaning in test case should not be dependent with each other. And next is quarantine gem and rspec retry. So this is more or less same, both are more or less same, where it tried to quarantine the failed test cases rather executing the complete container. It just quarantine all the test cases which is failing and retry based off of the configuration that you have given in the application level. So this is in both the gems you can give the how many times your application, the failed test case should be retried, and based off of that it just retry the failed one. And here I have just summarized all the best practices from the previous slides. So first is it's advisable to have the shared example, and next is database cleaner gem, which is most important in terms of transactions. Is just make sure all the state has been cleaned between the test cases. And next is factory box strategies, like make sure you're creating the test data using factory bot. Like you can just provide all the expected assertion, the attributes that can be set in the factory bot, and you can make the assertion out of it. And next is webmock that I have already mentioned, webmock and VCR, which is more interesting, and the transaction testing. And continuing to that, it's like we have other best practices as well in terms of capybara, add the wait mechanism, and also in terms of external services, add a wait mechanism until unless you are supposed to have the live communication between the applications, and maintain the test data properly, and at last regular maintenance, which is most important. So whenever you find there is inconsistent result from your test shoot, so make sure we are just fixing the flaky test cases then and there, and add a retry mechanism, which is added advantage. So I'll just end this with how Rentley managed to conquer the challenges of flakiness. So at the initial state, how it was like, when we are trying to deploy our code to production, we used to wait for 1 hour, more than that. And at last we were expecting that finally, yeah, I'm done. My code is deployed to production. I can see it live. And what happens really? So it's like, this is one of the containers, like we have 10,000 plus examples. This is like one of the containers result. So what happens is like, out of 1049, just 5 failures has occurred, because of which the CI/CD pipeline is blocked and my code is not deployed successfully into production. So it is like the time that is involved plus cost is involved is also increased, which is actually a pain point whenever we try to push our code, and there are a lot of deployments waiting in pipeline. So what we did out of it, like, then what we were supposed to do, like, we will check the code, whether it is working expected, or will be like whether it is going to create a code red, like, whether by changing all the code, which is creating the test cases flaky, or, a test case is failing. But, we will get the result like, yeah, my test case is completely working fine. Or, my code is completely working fine. Then how come it is creating the inconsistent outcome, right? So we'll have that question. And tend to rerun it. That's how it was, being followed, and that was like a pain point. And out of it, what we have, given as a fixes, and where we are having a smooth deployment now is like, so that I have just splitted that into three parts. So first is we have just resolved all the known flaky test cases. We have just prioritized it, all set, and allocated the resources, and fixed all the flaky test cases with all the strategies that I have given. With those are all like the live examples from the flaky test cases that we have faced. And the second is database cleaner, which I have mentioned to clear the states between the test cases, which made more faster of the test suits. And third is aspect retry. So with all the test cases that has been completed or fixed, we are not 100% sure that there might be some test cases which is underlying inside which create the flakiness in future. So in such cases, we don't have to wait or tamper the CI/CD. So we just had the retry mechanism where it is going to just isolate the failed test cases and it's going to run. So after implementing these fixes, here is the result. So first run after implementing it, it was like the 5 failures, the 5 flaky test cases. And what it does, like what this retry gem does is like, it takes these 5 failed test cases, like it just isolated and run the based off of the retry count that we have given in the configuration. So we have given like 3 attempts it can have for the failed test cases. For the next attempt, it just got passed and we got the clear CI/CD outcome. So all test cases passed, all set, and that code has been also deployed to production. So this is how we managed the result. And I'll just complete this. I know this is a vast area. I'm just wrapping up the things so well. So what is the outcome we got from the aspect retry? So the execution time of the RSpec run has been reduced by 50%, and the success rate of RSpec is also reached 100%, and the expense associated with RSpec has been reduced by 80%. So these are all the outcome we got from the Rentley application. So yeah, with this, I'm winding up. So hope this find helpful, and let's have a happy unit testing. All right. Yes.
Thank you, Maheshwari. Before I have even time to say that there is no time for questions, we have a hand up. So, okay, fine. We'll take one question because I know people are hungry.
So instead of implementing retry gem, shouldn't you actually fix the flaky text?
Yeah.
Yes,
So
fix.
yeah, that's a good point. That's a good question. We have just fixed all the failing test cases first, like with the 5 strategies that I have mentioned. We have fixed all known flaky test cases. But as with 10,000 examples that is underlying in our application, we are not sure that it might create the flakiness, right, which is underlying. We are not so sure about it, and we are that test cases might have passed successfully, right? So to avoid such test cases which is underlying, we have just implemented the retry mechanism, which it's going to create the other set of pipeline in the test cases, and it will just run and have the cleaner CI/CD pipeline. So that's
Okay.
the reason.
Thank you.
Yeah.
Awesome. Thank you so much,
Yeah,
Maheshwari.
thank you.